Hello guys, welcome to another video tutorial that continues from my previous video tutorial when I did mention that I will be doing another one to answer the questions from this pre-release scenario that we did last time of the reaction times for an experiment with regards to two schoolhouses, Saturn and Mars. If you're not familiar with what I'm mentioning, please check on my playlist for the IGCSE Past Paper 2 solutions, and you'll be able to see previous two video tutorials where I did explaining how to create the program for this pre-release scenario, and I did run the program as well. So I'm going to be focusing on the questions now to talk about how you can answer questions, because normally with the IGCSE exams, the questions pretty much repeat themselves. It's just a scenario that changes over time, but the way the questions are structured are pretty similar. So the first question says all variables and other identifiers should have meaningful names. Mostly the questions where you look at questions 1A to D are mostly related to the program that they asked you to create for the pre-release material, which is this basic one here for what we did last time. So the first question says that we need to declare the array that was used to store the reaction times for the whole school. And if you guys remember when we were doing the program, we had to create an array, a one-dimensional array or list that was called reaction time and was initially empty, which was later going to be storing the reaction times for the experiment. So that's the answer you're supposed to write down, because that's pretty much what they're asking you to do, is just to declare how you have stored the reaction times. Now they asked you on question 1AII, it says change the declaration so that the array can hold a sample of 50 students. So that means you're going to be putting the number of max of students. So this is one way you could do it, by writing again the variable name of the array, which is equal to, again, the square brackets to signify it's an array, a one-dimensional array or list, and inside you specify the limit of accepted data, which is 50. Or you could do writing 0 and you put a colon and you write 50. So there are many, many ways you can represent this, but this is pretty much the most simplest and straightforward way. Question III says, why is an array an effective data structure for storing reaction times? Obviously, this is a question that really does make sense. Whenever you use one-dimensional arrays or lists, they're very useful to store multiple options. Whenever you have multiple options or you have more than one sort of entry of data that you require from the user to be stored. So it's a very effective structure to use, where in this case you have multiple reaction times that you need to store under one single variable name, or you call identifier. It also reduces the number of variables that you can create. So instead of creating a separate reaction times for each student, you can all just save that under one single variable name, which is what we call the reaction time, or you can call it identifier. And inside of that square brackets, you're going to store multiple reaction times. Also, arrays have an index, which basically is used to represent the position of every element, so it makes it easier to access those elements. Again, an iteration loop can be used to go through the array like a for loop, and it allows for more efficient programming and easier debugging. Question B says, write an algorithm for task 1 to complete task 1 for the whole school, either using pseudocode, programming statements, or flowchart. Do not include any validation rules. So I have not included the answer for pseudocode or flowcharts. I guess that is something we could do in our maybe upcoming video tutorials for past papers, so that I could just show you how to do that. It is really not difficult. I'll try my very best to do that in upcoming video tutorials of how to write pseudocode and also how to write flowchart, and how you can actually run pseudocode to see how your program or your algorithm looks like before you actually create it as a program. So I'll do video tutorials for that one. But what I just did to answer this question was I included the programming statements that we have used in our program to basically answer the question based on task 1. If you guys remember, task 1 was all about entry of data. So it was mostly about setting up the one-dimensional arrays, which is just the age array, the schoolhouse, and the reaction time, and allowing the user to input that data and validating the data. But according to what we have here, it tells us that we should not include any validation rules, which means the rules that say, oh, if age is not greater than or equal to 12 and less than or equal to 16. So those validation rules, they have said do not include it, but just write down the programming statements or pseudocode or flowchart that you've used to complete task 1. So what I did was pretty much copied everything we did in task 1. So since task 1 was about setting up the arrays, I copied this part, and that's what you're expected to do when you have such a task in task 1 where it says you need to set up arrays. then you're just going to be copying the stages of where you declare those arrays or you created them. And again, task 1 is all about inputting data, so I copied everything from here. Of course, I changed the 1 to 0 and this 4 to 650, because if you guys remember, we're supposed to allow 656 students to enter this records of series of data. So I also changed that information, and I pretty much copied everything from the beginning year up to the end. This is where task 1 pretty much ends. And then I just remove the validation rules, because they say do not include these validation rules. So you just remove them where it checks to see that the house is right, that the age is right, that the reaction time is actually a positive number. So I just removed that, and I just included the part of declaring these arrays and basically specifying the number of students that can do the entry and the part of where students enter and where it's going to be saved in these arrays. So this is what they're asking you to do essentially. Now, question 1C says, identify 3 different types of test data that you would use to test your validation checks on the age input in task 1. So remember that task 1, the age that was supposed to be entered was between a range of 12 to 16. So what they're asking you is, I'm sure you guys, I'm not really sure if you have come across validation checks. This is something I will do later on in my video tutorials. I'll explain how validation checks work and what they are. But what they're asking you to do is to list 3 types of validation checks. So 3 types of test data. So test data is, I think, on unit 9 of this IGCSE computer science textbook, and it talks about ways of how you can test data using validation checks like presence check, format check. Like format check when you're asked to enter, for example, your ID, school ID, and let's say your school ID is made up of 3 capital letters from the beginning and then maybe 3 numbers at the end. So that's a particular format in a particular way of how you have to enter that particular data so it's correct. So that's what we call, for example, format check. So that's an example of a validation check. So they're asking you to identify 3 types of test data that you would use to test the validation check on age. And so age would basically be that the age has to fall, since the age in task 1 has to fall between 12 and 16. So the test data we have are basically normal test data, abnormal test data, boundary test data, and extreme test data, even though you don't see extreme in here, but it is also an example of test data. So if you gave only these 3, for example, if you said normal or valid test data, it means you're saying what kind of data will your program accept to be able to validate the age on task 1. And of course, for a normal test data, then it means your program would be able to accept any age that was between 12 and 16 inclusive. So this is why you're putting an example of test data, since they tell you to actually write examples of test data. Erroneous or abnormal or invalid test data would mean when a user accidentally enters an incorrect age or enters an age that should not be accepted by your program. Of course, it should be rejected. Then what kind of data would that be? And so that would be like when a user enters a decimal point, a number with a decimal point, which is not an acceptable age, or enters it in letters instead of numbers, or enters it below 12 or above 16 or none of that sort. So this would be what will be considered as abnormal data and will be rejected. We also have boundary test data, which is something that will be, we have 2 types of boundary test data, which is boundary test data that will be accepted and boundary test data that will be rejected. So of course the boundary, which means like the range of data that will be accepted, would be between, an example is between anything from 12 to 16. And then anything that will be, so boundary would be like the limits, 12 or 16. That's why they're saying instead of 2, it's 12 or 16. 12 being the minimum boundary and 16 being the max boundary. And then rejected, of course, would be anything like 11 or 17, because that's not part of the boundary that has been provided. So this is an example of the sets of answers that you can give for question C. Now, question D says, explain how you would calculate and output the average time based on the user inputs of age and schoolhouse as per of task 3. And any programming statements you use in your answer must be fully explained. Now, what I normally tell my students is always useful for these kind of questions to actually put segments of your code that relate to the question so it backs up your explanation as evidence. So that's what I did. So this coding that I have included here, I basically have already explained how I was able to find, or how my program was able to find and calculate the average reaction time based on specific user input. And what I said was the user was first asked to enter the age and the schoolhouse. Then the data that was entered was validated, of course, to make sure that the age falls in the range of 12 to 16 and the schoolhouse is actually between Saturn and Mars. Then I said the age and schoolhouse that the user entered was then searched by looking up for the matching reaction time in the reaction time one-dimensional array using the index position for the age and schoolhouse. So what this means, guys, is when the user, of course, if you remember in our program for task, I think that was task 3, when the user actually entered an age, we first had to validate it, and then we had to validate the schoolhouse. Once we did that, then we had to basically check and see the age, compare the age that the user entered with the age in the age array and see if there was a match as well as the schoolhouse. And if there was a match, then we were going to use that matching index position of where that age and schoolhouse was found to be able to find the corresponding reaction time in the reaction time array, which is where we stored under this variable called get reaction time. So that's pretty much what I explained in this block of paragraph. I said that the index positions for both the matching age and schoolhouse that was found in the corresponding age and schoolhouse array was then used to find the corresponding reaction time in the reaction time array. So then the reaction times that was found to match the user search are then saved. And then once I found that corresponding reaction time, we saved it in this new one-dimensional array called new reaction times, because that contains those corresponding reaction times, which I later then totaled, and I used the total reaction time variable to set to 0. So this was the way that I totaled these reaction times in this new reaction time array by basically creating a variable called total reaction time. If you guys remember, that was what we did. And we basically just summed up, we set it to 0 and we kept summing it, adding that total reaction time to those new reaction times that was inside the new reaction time array, of course, using a for loop. And after that had been totaled, then the total value was divided by the number of reaction times stored in the one-dimensional array to find the average reaction time. Alternatively, guys, you can also say that you use the sum function, which is exactly what I used here actually. I use a sum function to sum up the reaction times in the new reaction times array, and I just basically divided it by the number of reaction times by using the len function to find that number, and that was how I determined the average reaction times. And so that's pretty much another alternative of how you can explain this. And of course, I gave the programming blocks to segment to support my answer. So that's what you're supposed to do for these kind of questions. It is always good to give a very detailed explanation of what you've done, because that proves that, to the examiner going to mark this, that you actually did the program and you understand. And of course, always include segments of your program that does support this particular task. Now moving on, for question E, it says, explain how you would change your solution to task 3 to output the age of the student with the fastest reaction time. So task 3 was all about just outputting. If you guys remember, again, task 3 was mostly just outputting the average and slowest reaction time, and it was basically used to output just a specific age and schoolhouse. Well, based on specific age and schoolhouse, we were supposed to output the average and slowest reaction time. But now they're asking you, how would you change, how would you change your solution for task 3 so that you can just display the age of the student who had the fastest reaction time? So what you have to do here, obviously, fastest reaction time would mean the minimum reaction time, because if you had a reaction time of 60 seconds and another one, for example, 35 seconds, obviously the one of 35 seconds is the fastest because it's the smallest, 60 seconds is the slowest. So that's how you're going to explain it. So what I did, I said I would create a variable called fastest reaction time, and I'll set it to be the value of the first reaction time in the reaction times array. So what I did here was, instead of using, I could have said that I will use the min function, and a min function is a function that you can use to find the minimum value of a group of list of options in a list. And so I would use that min function to find the minimum reaction time in the reaction times array or list. And then that will basically tell me the fastest reaction time. So once I find it, then I will use the index position of that minimum value that I found to find the corresponding age in the age array for that particular value. And that's how I'm going to get the age. So I could have explained it that way, but one way I did explain was that I said I will initially create a variable called fastest reaction time, and then I'll just say it's equal to the first value that's going to be in the reaction times array, which of course I'm going to use a for loop to determine that. So I'll just say it's equal to reaction time, and then in square brackets I'm just going to put 0, which means the first value. So that's just by default. The reason I'll do that is because later on I would use an if conditional statement and of course the for loop to compare that fastest reaction time that I initially set with the other reaction times in the reaction time array. And then of course, if a smaller value is found, because you're going to start comparing the first one, or you're going to say, oh, since the fastest reaction time was originally set to the first value in the array, I'm going to compare it with the first one. Oh no, it's the same. It's not. You're going to say if it's less than the first value, and of course it's not less than, since it's the same. Then you're going to compare it with the second one. If it's less than, or if it's great, if you can say if it's greater than. And then if it's greater than, of course, then that means it's no longer the fastest reaction time, because you're looking at the smallest value. Then it means that the other value would be the fastest reaction time. So that's going to go throughout all of the values in the reaction time array. So that comparison is going to be happening until the fastest reaction time is found. Once it is found, the index position of that particular fastest reaction time will then be used to find the corresponding age in the age array. And this is possible since the records of age and schoolhouse have been done sequentially. So what I just added here was an extra note saying that it is possible to use this method of search to find the fastest reaction time, since what we have is basically age, schoolhouse, and reaction times that have been added to these one-dimensional arrays sequentially as the user entered them. So there hasn't been any mix-up. So obviously we will find the fastest reaction time. So this is another way to explain that one. Moving on here, guys, this is part B, section B of paper 2, and they always give you these parts where they ask you to look at the algorithm and figure out where mistakes have happened. It is always important to read the section carefully. I find sometimes students tend to because of not reading the section carefully, they don't really identify where the error is, or they identify errors that are not really considered as errors. So read this carefully. It says, read this section of code that inputs the ages of people entering an event. The input sequence is ended by inputting a negative value for age. So that means whenever a negative value for age is inputted, the sequence pretty much ends. The code outputs the number of people at the event over the age of 18. So these are keywords you must focus on. So now it says that there are 4 errors and you have to detect it. Obviously, we can first detect, if you look at this is fine, where you set the num18 variable to 0, because you're going to be increasing it by 1 to find out the number of people that are over 18. So this is fine. Inputting age is also fine. While age is greater than or equal to 0 is also fine, because it does maintain the rule of not getting a negative value. But here we can see that there is a problem on line 4, because it says if age is greater than or equal to 18, and we are seeing on the instructions here that the age has to be over 18, not equal to. So this should be just greater than 18. So the first error is here. We see that another error occurs on line 5, because it's supposed to be num18 is equal to num18 plus 1. Since it is incrementing by 1, it's sort of like a counter, and supposed to increment by 1 to find out the number of people that are over 18. So this should be a plus 1. We can also see that the input age has not been included in this while loop, which should, because if you remember how while loops work, they may never execute. And especially if you wanted to keep repeating, if you don't include the statement, it's not going to repeat. This is going to only happen once. So because it has to keep asking for age, this input age also has to be included before this line 4. So it should be there as well, which is not there. So that's another error. Another problem is on line 8. Here we say print 18, num18 minus age. This should not be there, because you're just printing the total number of people who are 18 years old. So it should just be print num18. So this is how you identify the errors for this kind of segments of codes, guys. And that's exactly what is here. Now moving on. On section B, on question 3, it says there is a program that stores the following data, and this has to do with more validation checks, again, kind of relating to both programming and database. Database is another topic that I'm planning to do video tutorials on, so I can explain both theoretically, and we can do also practical work on how to actually create a database, how to run a database, how to apply validation checks, and we will be doing all of that. So I'm hopefully going to be doing that over the summer as tutorial videos. If you would like that idea, just let me know in the description box. So this relates to kind of validation checks. It says there is a program that stores the following data: employee ID, which must be of 2 letters followed by 4 numbers. So that means basically it's a format, the validation check. So it needs to be just this. So this is what we call format validation check, making sure that the data, the employee ID entered is of that. And also it says by 4 numbers. So it says 2 letters followed by 4 numbers. So that means it could also be a length check because you make sure that it is 6 characters entered. Here it says a manager, so a program where it's asking for a manager, and the program basically says whether the employee is a manager or not. So it's basically saying, are you a manager? So it should be like something like yes or no. So that kind of example of data required is what we call Boolean, which means you have just 2 options, yes or no. And then we have annual holiday, number of whole days, annual holiday. So this is an integer, so this is the number. So that could be with more of type check, type validation check, making sure that a number is entered, or you could even say presence check, making sure something is actually entered. Pay grade, which means the employee's pay grade, which must be single letters between A or F. So this is also could be a type check, making sure it's just letters that are entered or characters, and could also be format check, making sure that capitals letters are just entered instead of lowercase. So that's an example of how you should analyze this kind of question when they ask you, because they say you should complete a table to identify the most appropriate data type. What kind of data would be required for employee ID, for manager, for annual holiday pay grade? We know employee ID could be a string or text because it's made up of text and numbers. Manager could be definitely a Boolean, and then annual holiday could be integer. And then pay grade could be letters or characters or string, mostly characters, I would say, because it's just A or F. So they're asking you to do that, to identify the data type for each variable and also identify the validation check, what kind of validation you're going to use in your program to make sure that the correct employee ID is entered and manager value, whether yes or no, is entered, annual holiday, the whole number is entered, and pay grade, of course. So this is what it should be. So employee ID could be string, like I said, or text. And since we're talking about program, I have to mention, please don't put text, because if you put text, it will be wrong. Programming relates mostly to string, Boolean. These are the data types. Text is for database. Text is a database data type. String is the data type for, something like this, made up of numbers and character, alphanumeric kind of thing. So it should be string, please, not text. Text is for database. Now, string is the right data type since it's made up of characters and numbers. So string obviously is the one. The type of validation that could be applied is like length check, making sure that 6 characters are entered, and also presence check, making sure that something is actually entered, or format check, making sure that 2 letters and then 4 numbers is entered, or type check, making sure that it is actually a string entered, not just numbers or letters. And so the same thing for manager, like I said, Boolean, which means a yes or no. So you could do a type check, making sure that, characters, text basically is entered, or presence check. Annual holiday, like I said, is integer, so it's numbers. So you could do type check, making sure only numbers are entered. Range check, so making sure that a certain range of numbers are entered, and presence check as well, making sure something is actually entered. Pay grade is also, again, using character data type because it's just A to F. And so the type of check could be presence check, making sure that something is actually entered, or length check, making sure it's only one particular thing that is entered, just one, not more than one, because it's either A, B, C, D, or E, or F. And type check, making sure that a character is entered. So that's how you answer that question, guys. Next up is this one. It says study the flowchart and basically create trace tables. So this is something that students normally find confusing as well. And so trace tables are basically created based on the flow of an algorithm. As you guys can see here, this flowchart starts with, it goes on, as you guys are already familiar, flowcharts are something I would be looking at again in upcoming video tutorials, but they're another way to represent, instead of before you program, you represent it as a sort of design of how you want your program to flow. For example, if you look at this flowchart, you can actually interpret it into a program because you know what should start, what should go next, and etc. I said where the conditions should be. So this is a flowchart that starts with inputting A, so A is a certain value, and checking to see if A is greater than 0. If A is not greater than 0, then you basically output a text saying exit, and then it ends the whole algorithm. If A is greater than 0, then basically it will set B, which is another variable, to be A. So whatever A was, B is going to be the same. Whatever A was, again, C is going to be the same, and it's put in this process box. This is what we call a process box. This diamond or rhombus shape is what we call the decision. This is where you have the conditional, like the if statements. And then this is where you kind of have like this, the programming statement where you say B equal A, basically. This is another process. If B is going to be equal to A and C is going to be equal to A, then B is going to be equal to B plus A, and then C is going to be equal to C minus 1. And then it's going to check to see that C is less than or equal to 1. If it is less than or equal to 1, then it's basically going to go back and output B and then output A and repeat all over again. However, if C is not less than or equal to 1, then it's going to go back here and continue with B. So let's try, if you're creating a trace table, the first thing you should do is know what the inputs and outputs are going to be. So what we can tell here is we have the inputs to be A, B, and C, and then we have a final output. So that's what you should have on your table. And we don't have anything else. That's pretty much what you have, just A, B, C. So you're looking for the main variables of your flowchart. That's what you always have to do, so you know what you're going to be putting in your table. So if you're starting, they always give you the values to use in your flowchart, and they say that use the value of A as 4, the value of B as 3, and the value of C as -1. The values of A as 4, and then A as 3, and then A as -1. These are not A, B, C. This is just all for A, because you're starting with A. So if you input A, which is going to be 4, so the first thing is if A is 4, so this is going to check, is 4 greater than 0? Yes, it is. So that means B is going to be 4 and C is going to be 4. So that's what's really happening on the first line. And nothing is going to be output. Then it continues. B is going to be 4. Since B is 4, so it's going to be 4 plus 4 because A was initially 4. So then B goes to 8, and then C is going to be 4 minus 1, which is 3. So B is going to be 8, and then C is going to be 3, as you can see in this row here. And then it's going to be checking, is 3 less than or equal to 1? No, it is actually greater than. Then it goes back to this part of this flowchart, and it continues. So B was initially 8, don't forget. So that means it's going to be 8 plus A, and A was still 4, so 8 plus 4 is 12. So B is now 12, which is what we have here. And then C was 3, so 3 minus 1, which is going to be 2. And then it checks again. Is 2 less than or equal to 1? No, it goes back again. So we get 12, we get 8, and 3, like I said, in that particular part where we get 4 plus 4. I already said that before, sorry. So we get 8 plus 4, which is 12, like I said, and we get 3 minus 1, which is 2. So this is this part, 12, 2. And so since 2 is not less than or equal to 1, it goes back again, and B is 12. So it's going to be 12 again plus A, which is 4, and it's going to be 16. And here C was 2, so 2 minus 1, which is going to be 1. So C is going to be 1. So you get 16, 1. And so here it checks, is C less than or equal to 1? Actually 1 is equal to 1, so yes. And it comes and outputs B, and B is 16, and then it outputs A, and A is still going to be 3 because it's taking the value of C. Remember, C becomes A, so A is C. And that's what we have here, 16, 1, it outputs 16, which is B, and it outputs A, which is 3, and it repeats the whole process all over again until it gets to the end of -1. So this is really what happens, guys, for this kind of trace tables. I'm going to move on. The next one says you should rewrite the following pseudocode algorithm using a while, do, and while loop. So that this is a very simple algorithm. They basically want you to write this in a while loop, using a while loop. Obviously, we know with the while loop, you always have to set a variable first, unlike a for loop. So you have input num, and since we're talking about counter should start from 1 to 12, we always have to set a, if we're using a while loop, we should have a variable that says counter equal to 1, and we say while counter is less than or equal to 12 inclusive, then we do num is equal to num times counter, and we do this as well, and then we end while instead of next. So pretty much that's what's going to happen. And of course, I forgot to mention you increase counter, because with the while loop, it doesn't go like a for loop automatically. Counter has to be increased and checked with this condition every time. So this is pretty much what it should be like. And the next one says, Explain the differences between a while loop and a do while loop and a repeat and until loop. So the difference between a while and do and end while loop is and a repeat until loop basically is that a while loop, whenever you write it, it may never run, but a repeat until will run at least once. So basically, for example, if counter was never less than or equal to 12, maybe you set it as something else, it will never run this whole block. If counter was 13, then this whole thing wouldn't run. But with the repeat until, you're basically saying repeat num is equal to num times counter, and you've already set counter to 1 and input num, and then the condition is after that. So it will at least execute even once. So that's the difference between how the two of them operate. And then the next one, which is question 6, is talking about a database table which is called device and has been set up to record the electronic equipment used in a small business. And we have the device ID, the device table. So these are all the field names of this database table. And this is all of the records that are inside of this database table or this database itself. Now they're asking you that the query by example below select certain records. They're telling you to tell them what the output of this query by example is. And if you guys are kind of familiar with Microsoft Access, you know that this is an example of how you do query in Microsoft Access using Query Design Wizard. If it's something that you would like to learn, just let me know in the description box and I will create a video. I'm hoping to do that, like I said, soon to explain how databases can be created and set up. So again, based on this query by example grid, it basically shows what will be the output. And if you look at this query by example, we see the fields selected are user, portable, and then the purchase price. And that's pretty much these parts here. So user, portable, and the purchase price. And we see that the tables are all selected to be device because that's where the data is going to be accessed. The sorting method should be ascending for the user, which means the name should be ascending starting from A all the way up. And it says it ticks the box show, which means it should show the data. So if you don't tick this box, it's not going to show you the result. And then portable, which is again gotten from the device table. And you notice that it doesn't show because that's not what it does. It's not supposed to show anything about portable, whether yes or no. So the box is not ticked. But the criteria, it should only select the device which is from the user, basically to select the name of the user, that it has the portable selected as yes. That's what it means. So when portable is selected yes, then the username should be selected in ascending order. And another criteria, which means another condition, so criteria is the condition, is that the purchase price should be greater than 1,000. So what's going to happen here when you run this query is that it's going to go back to the database table. It's going to be looking for all the yeses on the portables, and it's going to be looking for the purchase price that is greater than 1,000. And the only place we can see purchase price greater than 1,000 that has a yes portable is this one for Chantal Law, which is 1,460, and this one for Alan Swales, which is 1,700. And we can see that according to what is supposed to be displayed, that the user is supposed to be sorted in an ascending order. Ascending would mean that, of course, Alan Swales would need to be displayed first. And then because the user, the name should be in ascending. So Alan Swales would be displayed first, and then Chantal Law would be displayed next. So the output would be exactly this. If you write it the opposite way, you will get it incorrect because you're not, if you put Chantal Law first and Alan Swales, then you're not following the query because you should pay attention that the sort should be ascending. So it should be Alan Swales and then Chantal Law. The last question says, complete the query by example grid below to select all desktop devices that were either purchased before 31st of December 2016 or the cost was under 1,000. Only show the device ID and the device type. So they've already told you by saying only show, this is the show box. You're going to only be ticking for device ID and device type, and you have to enter the fields first. Based on this query, you know that you need the fields of date, you need the fields of price, you need the fields of device ID and device type. So if you look here, this is exactly what we have here. The device ID, the device type, the purchase date, and the purchase price. Sorry about that, guys. And the table that would obviously be selected is the device table, which is this main table from the beginning. And then it says that the date should be before 31st of December 2016, and the cost should be under 1,000, but you notice that there is a logical operator that says or. So it's not compulsory that it should be this and this. It should be either of this or this. So how you're going to represent that, you need to show the device ID and the device type according to what it says here, only show those two. So that's the only two boxes you're going to be showing. It also says that it's selecting all desktop devices, so not other devices but desktop. So you have to put that in criteria. And normally how we do that in database, we use the keyword like, and in single quotes we put what we're trying to search. The purchase date should be before, so how we write that, of course, is just like math. We use a less than symbol, but with dates in databases, you have to put a hashtag. So if it's before, it's less than. If they said after, you would use a greater than and a hashtag, and then you put the date between the hashtags. So this is less than, and then we put the hashtag and the dates in between. But it also says or the cost should be under 1,000. So which means that the cost where you have the or column, you're going to put the cost there. So it means it's going to be checking the purchase date or it's going to be checking the purchase price. So if any of these two are true, then it will display the device ID and the device type for a particular desktop. And this is where the questions end, guys, for the past paper that we were looking at last time. And I'm going to be doing my next video tutorial to look at a new past paper scenario and explain how the program is supposed to be created for that past paper. So stay tuned for that. If you like this video tutorial, please let me know in the comments box below. The comments does really help to tell me what exactly you're looking for. And also, if you would like to learn how to more about graphics design, this is just an actual additional note. If you'd like to learn how to do graphics design, there is a graphics designer who owns a graphics design gallery in Japan. I'm going to be putting his link to his slideshow on Behance so that you can check it out, and you could also contact him should you need to. You guys must have noticed that I have a new intro image on my video, so that was created by that graphics design house and gallery in Japan. So if you'd like to learn more, you can contact them as well. And I'll be doing another video tutorial to talk about the new past paper that we will be looking at. So thank you guys, and I wish you a great day. See you soon. Take care.